Alright, today we're going to learn about factoring by GCF, greatest common factor. Let's say we got something like this. Okay, so factoring is basically doing the distributive property in reverse. So that implies that when we factor, we're going to have a set of parentheses. And greatest common factor implies that we're going to find out what this one and this one have in common. So if you visualize 6 as 2 times 3, and if you visualize 5 as 10 as 2 times 5, you'll see that they have a 2 in common. Okay, so you also see that they have a y in common, and you see that they both have an x. Do not say they have 2 x's in common, because this one only has 1 x. So again, we said they have a 2 in common, so I'm going to put that on the outside. They have an x in common, and they have a y in common. Okay, the second part of this we should know how to do by this point. It's called the distributive property. So we just figure out what multiplies by 2xy. That gets us to 6x to the second y. So we know that 2 times 3 will give us 6. X times another x will get us to our x to the second. And we don't need another y because we're good with our y's there. We know that 2 times positive 5 will get us to 10. And since they both end with an x and a y, that's all I need there. So in other words, if you do the distributive property with this right here, you should get this right here. Let me give you one more example of factoring by GCF. Okay, so again, factoring is doing the distributive property in reverse. So we know we're going to have a set of parentheses. Then what we want to do, because it says greatest common factor, is find out what they all have in common. So I know that all 3 of these numbers are divisible by 2. This one has 1x, that one has 4 x's, and that one has 2 x's. So we can safely say that they all have at least 1 x. So I'm only going to put 1 x right there. This one has 2 y's, that one has 1 y, that one has 2 y's. So we can say that they all have at least 1 y in common, so I'm going to put a y right there. Now I'm going to see what multiplies by 2xy to get me to here. My 2 and my x already match up, but we need to get from a y to a y to the second. So we know that y times y is y to the second. 2 times positive 3 will get us to positive 6. X and x to the fourth, when I compare those, I see that I need 3 more x's. You can visualize a 1 there if it helps you. So it'll be x to the third. Do not put a y here, that's kind of a mistake. If you put a y here, y times y will give you y to the second. So we're good with the y's. 2 goes into 10, positive 5 times. X times x will give you x to the second. Y times y will give you y to the second. And I would double check my work by doing the distributive property. This times this should give you that. This times this should give you that. And this times this should give you that. So that's factoring by GCF.